Okay, last question, question 3. Notice it says using the trig identity, so it already tells you which one we're going to use. We have to show that this is true. Alright, so we look at this, and we look at that, and say, well, that sine A there, that's that bit there, and cos B, let's change the colour, cos B, whoops, sorry, is this bit here. So the B part is all of that, and the A part is that. Notice we've still got this 2 at the front. And we're trying to show it's that. Okay, so let's use it. It says to use it, let's use it. The 2 we keep at the front, and then we use this formula. A half sin, A, don't forget, is lambda, not lambda. I've forgotten. I haven't got something like that. And the other one in here, plus, plus, and the other one in here, and let's close that bracket down. This half and this half are the same, so they can become a factor at the front, and therefore they cancel with the 2 to leave us with this sin part and this sin. And notice that when we expand that bracket out, we get 2k plus, let's call it lambda for now, I'll think of the right name later, and exactly the same here. We expand it out and we get minus 2k lambda minus lambda. That means these 2 cancel and these 2 become 2. When we factorize that, if we need to, then they can come together. Do we need to? Yes, we do, look, because we've got sin, and 2, and then there is k plus 1, which will factorize. Now this here is an important fact. You need to remember and reflect on why, but on a sine curve, because on the x-axis, the sine curve is the same but opposite values, negative values. Okay, say numerical value but negative. Then sin of a negative value here is the same as negative sin. Also, we need to remember for a cos one that cos of negative theta is the same as cos theta. And that allows us to take the negative outside of there and replace the plus. And therefore, there is our proof, which we've been asked for. Alright, moving on. We now have to use principles of induction to prove this is true. Let's stick with P1 first. We could use the first term, but let's use the formula to prove it. Replacing n with 1, we get cos lambda, which is what we said. Right hand side, sin of 2 lambda over, which gives us sin 2 lambda over 2 sin lambda. Now, we're looking at this, and we're trying to see that it's the same as cos lambda here. It doesn't look like it at the moment, but we've got sin 2 lambda. If we look on our formula sheet, we know that sin 2a is the same as 2 sin a cos a. Don't forget this, lambdas are a, so we replace that in here. The sins cancel out, the 2's cancel out to leave us with cos lambda, which is therefore true. Fantastic. As always, we assume pk is true. I've highlighted that because we know we're going to need to use it later. And don't forget, this is a summation calculation. So when we do pk plus 1, it's exactly the same as pk plus the term for pk plus 1. We replace all of it up to k with the summation. That's why that's gone into there. And then we still have our pk plus 1, which I've expanded out a little bit. Okay, we've got a fraction and not a fraction, so let's bring them together. There we go. Now, you have to think back and think, why do they ask us part 3a? There must be a reason. And when we look at this, we'll see that that actually is in 3a. Well, this bit here, if I remember rightly, is in 3a there. So this bit here is from 3a. And that can get substituted in for this part here. The sin k, 2k lambda, and the negative cancel each other out. And therefore, we get what we're trying to prove, which comes down to here. And there's our proof. Easy as that. Very quick, that one. Much quicker than you think, actually. And then when we try and do values, well, we know that our lambda must be pi on 3 because the first term is pi on 3, so that is our lambda. And we need to find out how many terms we have. Well, to find that out, we know lambda is pi on 3, okay? And we've also got this part. So that allows us to say that if we know lambda, we end up with saying that 2n minus 1 is equal to 23, 2n is 24, n is 12, so there's 12 terms. And when you sub it in to the summation formula, which we had here, when we sub those values in, and you take care with thinking about what we get, we don't need to use a calculator too much. A 0 divided by anything is 0. And I will produce a little TI calculator video to explain that in more detail. Hope that makes sense. Good luck on Monday in your test, and thanks for watching.